Alright, the introduction to Arduino from an automotive enthusiast standpoint, video 2. We're going to be going over simple ins and outs today. I know some of you guys are probably gun-ho, definitely some of my new subscribers, about, oh, what about the boost controller, the transmission controller, and everything else. This video series I'm gearing towards people who have not done anything with Arduino. The first video was going over just a simple what is Arduino and what is the Arduino programming platform, what kind of boards you can get, starter kit, and a first simple sketch. If you've missed that video, I highly recommend going back to that one and watching that if you are new to this. This video, we are going to go into building simple in and outputs, button switch inputs, different ways of software debouncing. Gonna go into potentiometer inputs and just simple circuit building. So first part of this video is going to be circuit building. The second part of this video will be writing the Arduino code, and then the third part of this video will be both kind of configuring the Arduino code to get the Arduino to do certain things. We'll be going over how to map an input, flags, and other odds and ends. So let's get started. Okay, you have seen my my organizer before. I'm going to get, I only have a small breadboard. Where did I put it? There it is. I only have a small breadboard available today because the let's see, the transmission controller is running two breadboards. They're the actual nice big breadboards, and the small engine dyno Arduino controller has two smaller ones and a bigger one. So because of that, I need to buy some more, but this one will work for today because we're not doing a ton for the simple ins and outs. The next video I'll have to end up probably freeing one of those up or buying a breadboard so I can go over more inputs and outputs and start working with integration with like CAN bus and stuff like that. But so for now, this will work for this video for today. So and in your starter kit, you'll probably get a breadboard like this, and you'll probably get a bigger breadboard. Grab whatever one you want. The bigger ones have where you can feed them power and ground, so that might be a little easier than this guy, but this is going to at least give you the idea of what you have to do. So on a breadboard, I'm going to grab a wire, so hopefully see how well this camera does. So on a breadboard, you'll see these lines of pins. Let me see if I can get this close enough. Focus. Alright, see these lines of pins, like this whole line that goes down? Alright, each line that goes down is all together, so like these lines, or all these pins in a straight down row, are like all connected together on this breadboard, and the same way over here. Now, just so you know, I would check with voltmeter on ohms to see, but 9 times out of 10, like this pin and the pin directly on top of it don't have continuity between each other. So like all these pins will have continuity in a straight line, all these pins will have continuity in a straight line. They do not have continuity going this way and the same way up here. But again, just to verify with your breadboard, it's always good to grab a voltmeter. Even a cheap one, a cheap voltmeter will work. But just to make sure you have continuity just straight up and down these pins and not from cross to cross, which is what this breadboard's set up as. So, what we're going to do is we're going to do a simple switch input. So I'm going to grab an Arduino Uno for today's testing. And if you got your starter kit again, I'm going to go, I showed you this a little bit before. Most starter kits on that big website I was talking about that I still can't mention, thanks, anyway. So, come with a prototyping expansion board. I think it's called the GPI, yeah, Arduino, I don't know if you can read this. Closer, focus, focus. It says Arduino GPIO expansion board. So, anyway, what you do is you grab your prototype board, or shield, and you grab an Uno. You line up the pins, so all the pins line up so you don't break anything, and then you press them together. Alright, so all these pins up here, and they're labeled. Let me get closer to this video. They're all labeled. They interface with the pins that are on the Arduino itself underneath of it. Okay, so then you grab your ribbon cable, and your ribbon cable just expands it out. So your ribbon cable goes like this. The other side of the ribbon cable goes on the expansion. And then this, for the bigger breadboards, drops right in. It feeds, you'll see on a bigger breadboard, there's pins out here that are labeled positive and ground on both sides. It will feed power and ground to both of those pins. And then these pins in here, for instance, if I were to hook this up, try to get this in frame, which I actually might do for this video, like that. So all these pins right here, like A1, A2, A3, A4, A5, focus. Yeah, A1, there we go. Okay, so A0 through A5, and then it brings out the digital inputs too. And it brings all those right onto the board, so you can just hook wires from there and go forward. I'm actually probably not going to use this setup for this video because there's not enough breadboard here to do all this. So I'm going to take it all back apart. But just to show you, for simple prototyping, once you get an actual breadboard, and I have them, I just don't have them available right now, it makes life a lot easier for when you're just building and learning and stuff like that. So I'm going to take apart the shield and take apart my breadboard off the expansion board. Maybe these yellow ones are really stiff. I think they have an adhesive back on them, so they might be so well you can put them in a project box and just leave them. I personally am building circuits out of old, I guess it's prototyping boards, not prototyping boards, like the in-hole boards. Anyway, so all right, moving on. To build a simple switch input, we'll need power and ground. We'll need a resistor and a push button, and I believe I have one available. I might not. I thought I did. Alright, I guess I'm going to have to go get one from, I probably might steal one from the dyno, or the transmission controller I have. I'll just go bring that breadboard too, so just give me a second here. Alright guys, I'm back. So I brought out my Arduino transmission controller to grab a button off of it. So anyway, just to show you guys the breadboards I was talking about. See if I can come close. See how it's got the red and blue? So the blue would be ground and the red would be positive. And this guy literally just presses right in there. So these middle pins right here get separated between these pins on that line. And then the powers and grounds from the ends just feed these lines, so that way you have all those powers and all those grounds. And it works for the smaller breadboards too. I'm not using any of these for this today because I have it all set up for my transmission controller, but I am going to grab just a button to show you a button input. So let me set these aside and grab a button. And you'll get, I'm guessing, 5, 6 buttons on a starter kit. They vary, but for the most part that's what you get. And I'm just literally using all of my buttons right now, my prototyping buttons, on projects. Mainly my transmission controller, boost controller, and my small engine dyno. But anyway, so trying to stay in frame here. Take just your button and make sure you go this way across the pins. So, and these buttons normally go like one pin and then the third pin over, so we'll do that. I might switch to that one's a little soft from using a lot. This gets used quite a bit. Alright, so that one will hold good, and you can hear it when you press it. So anyway, so those are the outer pin, and then the third pin in is what's hooked to right now. So, alright. So now we need to, in order to do this style setup, you have to do a resistor, either to bring it down or bring it up. They're called pull-up resistors. I'm gonna use a pull resistor to pull it down, which I'm gonna go over what this means. So, 10K resistor, which I already know what this one is. 10K resistor is what I recommend. That way you're not putting a lot of amperage draw on the Arduino power circuits. So, and what I normally do is take one side and just jump from lead to lead, or from like side to side. So that way this is this whole rail right here is resisted to that rail where the button's hooked up to. So, and this side's going to be hooked to ground. So, we're going to take and let's see if, yeah, I got a whole new roll of black wires. I'll just use a couple for this video. So, give me a second here. Got some stuff in my pocket that's digging in my side. Okay, so we've got, I'm going to use, we'll say the gray wire. I'm just grabbing a whole rail of these that are all male on both ends. So you're gonna grab, and I hook it up just in the same side, the same rail that the resistor's on, and this one's gonna go to ground on the Arduino. So you got two ground pins that are in the, there you go. See the two ground pins right there? They're white. So you're gonna hook one of these to ground. All right. So. Alright, so that wire's hooked up to ground. Now you're going to take a wire, the other side's going to get fed power. And there's a trick to this. So I'm going to split this guy up just to make this visually appealing and get a red wire out of here. So, red wire for power. There's a 5-volt pin. So, if you look at your Arduino Uno again, I'm going to try to get this thing to focus. Right there it says 5V, which is 5 volts. So you got your VIN, which is voltage in. And that they have it regulated where you can put like up to 14, 16 volts into it. Don't recommend it. That's also the same pin that this is hooked up to for like a 9-volt battery. Anyway, then you got your ground, and you got your 5-volt power out. So we're going to grab that 5-volt power pin. Alright. And this time, we're going to go on this side to this other lead of the button and switch input. So, third one over from where you put your resistor ends, fine. See if I can get this to, there we go, push in. So, there's that. Now, your trigger from your button input is going to be on this far lead where the resistor is hooked up, but before the resistor, so between the switch and before the resistor, you're going to take that out to either a digital or an analog in. Because this is a digital input, like it's on or off, we're going to hook it up to a digital pin. So we're going to hook it up, let's see, we're going to take, I guess I feel like 3 today. It is Saturday, so I guess it's 3. Anyway, so you're going to hook up, I'm going to press this in. So, see if I can show you here. So, you can see the resistors going into that pin on this side, and then you got that wire between the resistor and the button switch. That is your signal out now. And I'm going to explain how this works in just a second here. I'm going to hook it up to, oh yeah, pin 2. Pin 2 sounds fun. So we'll hook it up to pin 2. Okay. So what's going on here? In case you're completely new to electronics. So, we're taking 5 volts from 5-volt out from the Arduino board and putting it to this side of the switch. So whenever we hit the switch, it's taking that 5 volts and going across here to this blue wire, and I'm applying this number 2 to 5 volt. Now, you're probably thinking, you have ground hooked up to this side. I do. It's resisted ground. So what's going on is, whenever you are working with microcontrollers, say for instance I didn't have this ground here, this other wire was just hooked up to pin 2, and that was it. Whenever you hit the switch, it would bring pin 2 high, so it would bring it up to 5 volts. Whenever you release that switch, because there's nothing electrically related to that chip from that, or for this video, there's nothing related between that chip and that pin 2. There's nothing to pull it down. There's like very, very little load. There is technically, but for the scope of this video, we're going to say there's no load. So because of that, whenever you like hit the button, bring this wire up to 5 volt, and release the button, that wire will stay 5 volt for a considerable amount of time. Ask me how I know. So because of that, the program will think you're still on the switch when really you're not. So in order for it to do, or for it to know, okay, I'm off the switch, we put a resistor to ground to it to pull this wire back down. And what I was saying earlier in the video is if you have a lower resistor than 10,000, I think this is 10,000 ohm, but say for instance you're using 1,000 ohm or 330 ohm, which is what the starter kits come with, it would technically work. But because whenever you hit that switch, you have resistance to ground at that moment, it's going to put the Arduino under the 5-volt pin and the voltage regulator underneath a lot of load. So, which isn't the greatest for it, and it's not really needed just for a switch input. So 10,000 ohms resistance to ground is fine. That way, whenever you're on the button, there's so much resistance right here that this practically has very low amperage draw to ground, so that way you're not shorting, because if you had a little lower resistance or no resistance, it would be a short to ground. So we're trying to avoid that. So again, just a 10,000 ohm, 5,000 ohms a little less, but it would still work anyway. Higher ohmage the better, as long as you don't go ridiculous. Just so that way whenever you hit that switch, it's not shorting the circuit to ground, but it's pulling, once you release the switch, it's pulling it back to ground, so that way the controller knows you're off the switch. So that is a simple switch input. And you can do them the other way around, where you're like, you have the pin resisted to high and then hit the switch to bring it to ground. That's possible too. This is the way I just kind of used to it, so that's the way I do it. To each their own. It's really not a big deal. Anyway, so that is how you do a switch input. Now, I think I will also go over a potentiometer input while I'm right here, and then we will go into software side. So, we're just going to leave that the way it is right now, and I'm going to grab a potentiometer, which I should have one available. If not, I'll grab one out of my box. Yeah, there it is. Okay, so potentiometer. For Arduinoing, there's a lot of potentiometers available. You have them, like I have one. I don't think this is it. No, that's not it. Okay, anyway, they make a ton of them. I use ones that are rated. Let's see if I can get this to focus. Focus? Okay. See how that says, like, there we go. B10K? So, it's 10,000 ohm between that pin and that pin. Alright? And then this center pin is your signal out to the Arduino. So, I highly recommend 10,000 ohm. Higher ohmage would probably be okay. 10,000 ohms seems to work fine for me, and it works for a lot of other people too, but going less means the same thing as the resistor, as if you're hitting the button, except this is constant. So you're putting 5 volts to this one, you're putting ground to this guy. Alright, so, and it's constant, so that 5 volts is going through a 10,000 ohm sweep and then going back to ground. So it's always putting a load on the Arduino. That's why I recommend higher ones. You can find these that are like for guitars and stuff, or video, or sorry, for audio stuff, that's like 25 ohm. That's way too low for ohmage reading for one of these, and it would fry. It might not fry, but it's going to hurt the Arduino over time. So highly recommend 10,000 ohm potentiometers whenever you buy some. You normally get 1 or 2 in a starter kit. I bought another 10-pack. I think it was like $5. And you'll find out most of this Arduino stuff is dirt cheap. That's why I'm kind of why I got into it. But anyway, so you're going to take your potentiometer, and something to know also is the way we set them up. So see how I have this right here. Focus? Focus. Okay. See how this guy is pointed to this pin right now, and I've got it turned all the way down. Then you can go all the way up to that pin. Okay? So, what's going on is, say for instance you want this to be all the way down, and you want to turn it clockwise to turn it up. That means this pin must be grounded. This pin must be high, or 5 volt, and the middle one's always your signal. Now, say for instance you wanted it the other way. that to be all the way down and turn it up this direction. Alright? That means this pin has to be ground and that pin has to be power. So whatever you want your potentiometer to be in the off position, it needs to be pointed to, whenever you got turned all the way to where it stops, physically stops, that pin needs to be ground. So I like to have them on this way and then turn them clockwise to turn them up. It just seems normal to me. Some people may think otherwise. This is how I'm going to do it. So for this video, I'm having it set up to where all the way counterclockwise is off and all the way clockwise is on. Alright, so you're going to put the potentiometer on your board. This follows about the same way the switch does, which means it skips every other pin. So see if we can get this thing to focus. My word. Okay, there we go. See how it skips every other pin? So that switch is the same way. So you just press it in, and these yellow boards are a little hard to press in. They press in pretty firm. But okay, so it's pressed in right now. So this one's a little easier, and I'm going to steal some wires off of what we already have. So we have the 5 volt going over, and we have ground going over. So because of that, I'm just going to jumper some of these on this board, and I'm going to get you close-ups for that. So I got an orange wire sitting here. Let's see, I gotta remind myself. Okay, so the going all the way to the clockwise pin is going to be your power. So this one is going to get fed to your power pin right here. Boom. So it's getting power from this 5 volt. That's getting fed over here. I'm just taking it from there and feeding power into the potentiometer. Now we're going to give it a ground, so I'm going to find a black wire. Here we go. Black wire. We're going to take the ground side, or the side that's all the way counterclockwise, which is this pin over here. Just so you can see what I'm doing. Press the pin in. Then this is the ground wire, which is gray, coming from the Arduino. I'm just going to get on the other side of this, so it's in the same row. Alright, press it in, maybe, there you go. So, pretty much, if you can see this ground wire is going into here. Then it's on the same row, taking that, going over to the potentiometer, and then it's just jumping that one little line to the potentiometer's ground pin. Okay, so next pin's your trigger, which is going to be the middle one of those 3. So I'm going to take, I normally like to do green for a signal because I'm a Ford tech that's pretty good with GM stuff for some reason. Ford does it too on the older stuff, but green normally is a trigger. So, and you can use whatever color you want. I just, for this video, it's going to make life easier for you guys to see what I'm doing. So, the green is going to go into this middle pin right there, press in, and that pin is hooked up to the middle pin of the potentiometer. And then you're going to take this, and I'm going to feed it into a 0, which is right there. Focus. There we go. See? So A0. You have A through 5 you can use. I'm just using A0 so that way I can show you some stuff with the coding so that way you catch on right away. But anyway, so there you go. So you have a button switch input. Alright. And you have a potentiometer input. Ta-da. Now we have an LED on board, which is right there, which I showed you in the first video. We're going to use the button switch input to change. I might do like a advanced blink or something, so that way you'd like changes levels or something on the. I'll figure out in the code what I want to do. I haven't decided yet for this video, but and then potentiometer output. I might just read it off for now, because once you start learning this stuff, you'll be able to get in your mind what you can do with this, and just being able to read it off through serial monitor, which I'll show you what that is too in this video, is very handy, so that way you can use it for different programming. So for right now, I'm just going to set it up like this, and we'll go to town. So that is how you physically wire one up for a button switch input and a potentiometer. And as I said, the button switch inputs can go on any digital pin. The Megas have up to 52, 54, something like that. And they can also technically go into analog pins. I've done that before when I've run out of digital pins. There's a little bit with coding. I will talk about it probably in a future video. We won't go into that right at the moment. And then you have your analog inputs, and the Arduino Uno has 5 analog ends. Mega has 15 analog ends. You can, but anyway, and you hook up potentiometer stuff like that. A rotary, I believe a rotary encoder would go into the analog pin, so on and so forth. I could be wrong in that. I am getting, just so people know, I'm getting a rotary encoder so I can start playing with it. So don't hold me to that right at the moment. But for potentiometer inputs, they go into the analog pin. Okay, so now I'm going to go into how to set button switch inputs up into the Arduino. Software debugging in different ways, or sorry, software debouncing and different ways of debouncing a switch, because there's multiple different ways, and getting the analog input into it, and serial monitor and stuff like that. Okay, so moving on to the Arduino coding for what we just wired up on the Arduino. So we need to set up the inputs. So we've got the button pin, or the buttons hooked up to pin 2, and the potentiometer is hooked up to pin A0. So we need to set those up. So we're going to save them. If you remember from the first video, we're going to save them because they're inputs. We're saving them as constants, so KO and ST. And then the pin for, let's see, constant for, we'll name it, or we'll set it as a byte. Save it as a byte. And we'll name it button pin. And it is on pin 2. And to comment out on the code, this is the pin number that the button is inputted to. I'm not an English major. I know that's probably spelled wrong, and I don't care. So moving on, let's see. So we need to set up the constant byte dial pin, and that is now. And here's something you need to know. Anytime you are referencing the analog pins on Arduino, you have to type a capital A in front of them. So this one is A0. You have 0 through 5 on the Arduino Uno, and you have A0 through 15 on the Mega. We have this hooked up to A0, so you have to this is the only time you have to do it, but you have to do it, refer to it as A and then the pin number. So this is the pin number that the dial or potentiometer is inputted to. Okay, so there's that. Now we need to save up or save information placeholders. So we are going to, these are not going to be constant, so we need to set up, let's see, trying to think here. We need to set up the dial or the potentiometer mainly. So we are going to save it as a volatile because it's an external input. I have found out in my Arduino research and development and just testing at home that any kind of output or input that's an analog reference or RPM or such of the sort, you have to use, or I highly recommend saving it as a volatile input. That way, on compiling, the Arduino program knows that this is going to be modified by an outside source. You don't normally have to do it with button inputs per se. That may change. I'm not totally sure. Everything I've done with a button input's been fine, not saving it as volatile. But you have to save anything that you do for interrupt. You have to save as volatile, and which I'll go into in a later video. And I highly recommend any kind of potentiometer knobs, RPM inputs, analog inputs. Highly recommend saving them as volatile. So, and I'll totally misspell this. Oh look, there we go. So volatile. We're going to save it as an integer. And we're going to be dial read. And we're going to set it to 0 on power up. So, alright, now this is the info placeholder for the dial input. Now this next thing is where we're going to have the Arduino map the input from the dial or the potentiometer to more of a human recognizable output. So we're going to map that reading. So we are going to save, and because the Arduino is doing this, it's not an outside source. We don't have to save it as volatile, so we're going to save it as an integer again. Mapped dial read in. We're going to set that to 0 on power up also. And this is the info placeholder for the dial input. Or info for the mapped dial input. Okay, there we go. So we have the button input in pin, and we have the dial pin set up. We have the dial reading placeholder and the mapped dial reading placeholder set up. So we need to go into void setup, and goal of this sketch for today, just for explanation, is going to be with the button pin, we're going to use the button to turn on and off the onboard LED on the Arduino. So like you hit the button once, it'll turn it on. You hit it twice, it'll turn it off. The third time we'll turn it back on. The fourth time we'll turn it back off, so on and so forth. And then we're going to take the analog reading from the knob, the dial, and print it on the serial monitor, so that way you can see like where exactly that knob is between 0 and 100. So that's the goal of this sketch and the goal of this little project for this example in this video. So we need to pin mode the Arduino to let it know the two pins that are hooked up to the one for the button and one for the potentiometer. It needs to know what pins those are, and needs to know that those are inputs. So, and before I go there, I need to set up the LED for an output. Just realized that. So constant byte LED pin, and that's on digital pin 13 on the Arduino. This is the pin number of the onboard LED. Okay, so now we need to set up pin mode. So pin mode, button pin input, pin mode, dial pin, oops, my bad, input, pin mode, LED pin, and that's an output because that's the onboard LED. Okay, so now we've got all the pin modes set up. It's button pin, dial pin, and the LED pin. So the Arduino knows once it goes through the void setup, which is the first thing it does once it's powered up, that those pins are inputs and outputs. So after that, because we're going to be using serial monitor to monitor the position of the dial or the potentiometer, we need to begin serial communications in setup. So you literally, this is all you have to do is capital S for serial, period, begin, and then you're putting in parentheses the baud rate, which for an Arduino Uno is 9600. Now the baud rate for a Mega is 11,500, I do believe. I could be wrong. Arduino reference would be able to tell you that. But for this video, we're using an Uno, so serial begin is on 90, or serial begin for 9600. Baud is fine, and that sets up the communications with that. So we should be in the setup. We should be done in setup. We might have to go back. No, wait. Correction, we're not done yet. So whenever we turn on serial monitor, and you'll see it in the video, it is going to print whatever is in setup and loop. If you want the thing to, for instance, for like data logging, if you were going to use serial monitor to data log, you would want to put all, like, for instance, your parameters, like your RPM, TPS, coolant temp stuff. You'd want to put the designation in serial or in void setups. That way it only prints it on the monitor once, because remember, setup happens once at the beginning of power up. The loop happens every single time as fast as it can go through. Like, it goes through the loop, then starts back at the beginning of the void loop, and just keeps going and going and going until power is taken away from the unit or something else happens. So because of the fact that we only want to print this line of code once, we're going to do serial.print. This means, hey, I want to print something to the serial monitor. If you want to print actual text, this is what you're going to do, and I will show you what you have to do to print like the read out numbers later. So this is for text. We're going to parentheses, quotation mark, and this is going to be the mapped dial reading. And I mean, you could change that to whatever. I know in the data logger I have this set up as TPS for throttle position sensor, or RPM for the RPM input, so on and so forth. So that right there sets it up for the map dial reading. Oh, and you have to, something you need to know about serial print. So for instance, this right here, the mapped dial reading, it will, whenever you do that, once it gets done with that, if you had this in void loop, it would print this, and then print it, and then print it, and it wouldn't enter. Like, it wouldn't go down. It'll just go left to right until it's out of room on the monitor. Then it will hit enter, or on its own, and then start another line. Or if you did this, like serial print this, and then your loop you had set up to serial print, we're going to do the maps dial reading. It would just map dial reading, map dial reading, map dial. So it'll be a bunch of zeros to 100. It would never like press the enter button to go down to the next line. The enter button on serial print is right after print. Type L in, as in Lucy Nancy. So once you do that, once it prints this on the serial monitor, it is going to do this. Literally, it's going to tab down or enter down, and then type the next, whatever you want. It's going to type that on the monitor. So as long as you have it in the serial print markup. So anyway, so we've got the button pin modes, or the button set up, the information was set up. We got the pin mode set up for inputs and outputs. We began serial communications, and we printed the first designation for what we're going to be printing on the serial monitor, which is going to be the maps dial reading. So now we're going to go into the void loop where it's actually going to do this. So what we want to do is, and we're going to be using if statements, and I said in the last video, if you don't know exactly what I'm talking about, this is the Arduino reference. Highly recommended. I'm actually going to bring up the if. It's under structure, and it's going to be if or else. So the if statement checks if a condition, for a condition, it executes a preceding statement or set of statements if the if condition is true, and the else happens afterwards. So I think they have it on here, maybe not. Well, they do underneath C also. I'm not going to go there. but for right now we need to know the if statement, and this is what it's going to do. So we're going to digital read, oops, and highly recommend, I'm going to give you guys a little tip here, copy and paste is your best setup. So short code for this, or the quick way of doing it, is highlighting what you need on your keyboard, hit Control C, that'll copy it, then bring it down here, Control V will paste it. Highly recommend this because of the fact, like that mopped dollar reading, if I mix one letter up in that, writing this out below, it will totally screw with my day. It won't compile correctly whenever you go to click the verify compiler. It will give you a heads up that this isn't available, yada yada yada. Yeah, it's not nice. So anyway, highly recommend getting used to Control C, Control V. You'll probably hear me saying that during this video. Something I forgot to do earlier also. So before we go into this, I'm going to back out of this. Before we go into if statements, I need to talk about debouncing. So debouncing of the switch. You may have heard it. There's two different ways of debouncing switches. You have software and hardware. So what the term debouncing means is, just watch my cursor for a second. So you have a switch, like say this is low and up here is high. So whenever you hit the switch, the reading goes from here, it goes straight up to high. But because switches aren't perfect, they have, even like the little switch you saw me use for prototyping, will create a little arc inside of it. So that arc will make the reading do this. So you'll have it low, it'll go high, low, high, and then stay high. The Arduino is so fast in reading that it will read that little blimp of high and then read the next high and think you hit the button twice, when really you only hit it once. It's just bouncing between high and low. So in order to, there's two different ways, actually there's a few different ways of doing software style debouncing, which is what I normally pay attention to, because hardware, you can debounce a switch using hardware, but it's normally more expensive, and I'm sure a lot of you guys know me, I do everything on the cheap. I'd much rather just do it in software because it's a quick couple types of characters, and boom, the switch is debounced. So we need to set that up here. We are going to do the quick and dirty way of debouncing for this video. I will go into how to debounce a better way in later videos. This style does work. I have used it in the advanced boost controller setup where time isn't necessarily an issue. I don't use this style in the 480E controller because time is an issue on that. So just so you're aware, this isn't the be-all end-all for debouncing a switch, but for a simple application like even like the boost controller where you're setting up like the advanced boost controller where you have an A and B input, and I could probably put all the way through Z inputs on that thing. But anyway, try not to ramble. This style of software debouncing works just fine for stuff like that where you're setting up the code before you're actually going to use it. I think I have this style debouncing in the 480 controller just for the trans brake because it works really well for that. But that's pretty much the only part of that code I have this in, and everything else I use a different style debouncing, which I will go into in a later video. But anyway, for this style debouncing, we need to set up an integer debounce timer, and we're going to equal it to 250. So this is 250 milliseconds because the human hand, for the most part, actually I think you can do it in I think I've timed it. I've literally built a code to time it. I think you can do it in 100 milliseconds, but for the most part you're not going to hit that button and release it within 100 milliseconds. So anyway, we set this up so that way the actually let me just hold on. So this is the time for the debounce function in milliseconds. I forgot I. Milliseconds. Okay. So, as I just commented out there, this is the timer for the bounce function in milliseconds. So the 250 is 250 milliseconds. I do it this way. That way, you could use the delay 250. But if you had, or if you're using this style debounce in, like, say 700 lines of code or 800 lines of code, like my 4L80E controller is, and you had to go through every line of code to change the debounce time because you're switching from like a prototype switch to an actual like automotive style switch, and you need more or less debounce time, you would be going through 700 to 800 lines of code to change one parameter. Don't like that. I like doing things the easy way. So this is pretty much a global, a global setting. So I only have to change that one number, and it changes all the debounce functions throughout the code. So, okay, now that that's set, we're going to go and actually show you how to use the debounce and how to use the if statements all in one shebang. Hopefully I don't lose you guys. And if you guys have any, this is something else, I'm going off topic a little bit, but if you guys have any questions about this video, or if you need something explained better, comment below. I will go into your questions or comments in another video, or possibly the next one. So we'll go with that. And also, just, I know this is mid-video, but this code, once it's done, and the video is posted online, this code will be, you will be able to find this code at twistedbuilds.com. I'll have it posted underneath the, I need to start a page on there for the introduction to Arduino. It's not up yet, but it's going to be. Probably by the time I post this video, I'll have that up, so you can go right to that page. This will be the introduction to Arduino from an Automotive Enthusiast standpoint video 2 in the series, and that page will have this code posted to it. So that way, if you want the code, it will be there. But okay, going back to the subject, if statements to control the button to turn on and off the LED. So if we're going to digital read, and it's going to be the button pin. Digital read, control V, button pin is equal to high, curly brace. Whenever you hit the curly brace and you hit enter, the program automatically puts the other one. Now, if you click right beside of it, it's going to circle where that curly brace is. So, for instance, if I was missing one for the void loop, I could go all the way to the last one in the sequence, click it, and it would show me where it's stopping in the code. It comes in nice for debugging, and definitely if the compiler kicks you from compiling the code because there's something wrong like that. I've been coding this stuff for close to a year now, and I still make mistakes like that, just so you're aware. So, it does come in handy. Anyway, if the digital read of the button pin is high, we're going to take, I forgot to do another one. So, the bounce timer, and this is going to be, we're going to count button presses. So, an integer, this technically could be a byte, but just for the sake of whatever, I'm going to do it as an integer. Integer button counter. And we're going to set up a 0 on power up. This is an info placeholder for the button counter. Okay, so going back to the void loop, if the digital read of the button pin is high, we need to increment the button counter from 0 to 1. So there's two ways of incrementing. And it kind of matters what you're doing. So if we're going to be just doing button presses, you can just have this increment positive to go up. So for instance, alright, so digital read button pin. Oh, I didn't go over that. So the 2 equal sign versus the 1 equal sign. The 1 equal sign means you are setting, like for this, we set button counter, it equals 0, the end. Anywhere else in your code, and you'll see this going down, I'm going to about do this in a minute. Whenever you set, like for instance the rollover I'm about to do with the button counter, whenever you use one equal sign, it means you're setting whatever you put before it, like this is button counter, you're setting it to 0. The bounce timer is equal to 250. You're setting that name of that parameter to that value. So, when you use two equal signs, you're comparing. So, digital read, if it equals, and that's or compared to high, then you go on. So you got to be careful with that in your code, because if you use one, if you're thinking you're trying to say, for instance, we're trying to compare the dial read to the mapped dial reading, and you used one equal sign. Say, for instance, you had dial read equal mapped dial reading. Dial read now equals mapped dial reading, not compared. So just something to be aware of. Whenever you're doing a comparison, you need a double equal sign. Whenever you're commanding that value to be that number, you're using one equal sign. So, okay. And going back to what we were doing, if the digital read of the button pin is equal to high, we are going to increment the button counter. So button counter double plus increments 1. So, for instance, we're going to go through, if that button was high, we would increase the button counter. So it would go from 0 up here to 1. Now we're going to debounce the switch, so delay, copy this, Control C, Control V. So now this is 250 technically, and if I needed to change the debounce time, all I'd have to do is literally come, like say I wanted it at 300 milliseconds, 300, so on and so forth. I'm going to go back to 250. That seems to work pretty good in my R&D. Again, most of my R&D so far has been with prototyping switches. I'm going to find out pretty soon with the transmission control module what kind of debounce time I need for an actual, like an automotive push button switch for like the sloppy trans brake and paddle shifters and stuff like that. And some of those are using a different style debounce function, just so you're aware. They're not all like this. So anyway, so we got the debounce timer set up, and that if statement's done. So if the digital read of the button pin is equal to high, we're increasing the button counter and delaying for the debounce time. That way it doesn't like increment to 2 or 3 or so on and so forth because of the switch bouncing. So now the next part is going to be, oops, notifications. Okay, so if the digital read, sorry, no, we're going to now, if the button counter is equal to 1, again, not equal, equal to 1, curly brace enter, and scroll down, we are going to digital write the LED pin high. This will turn on the LED. Alright, and that is it. So if the button counter is equal to 1, we're going to write the LED pin high. So pretty much you give power to the Arduino, the button counter is at 0. You hit the button once, it's going to jump the button counter from 0 to 1. If the button counter is 1, the LED is going to be on. Now we are going to handle a rollover situation and get it to turn off on the second button input. So next statement is if button counter, oops, helps if I could type. And again, this is where copy and paste comes in kind of handy too, is equal to 2. So we're going to digital write LED pin low, and then button counter, I can't spell, is equal to 0. Now see how I did that. Let's scroll down here. So And just so that way you can see the logic behind this void loop. Again, if the digital read for the button pin is equal to high, we are increasing our button counter and delaying for a debounce. If the button counter is equal to 1 because we hit that LED pin and it increased the 0 to 1, we are writing the LED pin high. If we hit the button again, which is going to increase the counter to 2, we're going to digital write the LED pin low or off, and the button counter is going to be now equal to 0. This is a rollover. So the second time you hit that button, it's going to turn the LED off. It's going to set the button counter to 0. So that way when you hit the button the next time, it's now going to increase the button counter from 0 to 1 and just keep going through this cycle. That is how you can do switch inputs, and you don't have to do it this way. We could also do it like you could use a microcontroller to turn on and off, say for instance that LED. Like for instance, you hit the button and you're holding the button on, it turned the LED on. You let go of the button, it turn it off, just like a regular switch, which at that point is kind of needless to have a microcontroller or an Arduino, but you could do it that way. That way comes in nice for, again, the sloppy trans brake. You don't want it to just turn on and have to hit the button again to turn it off. So that way I have it set up, if you're on the button, the trans brake's active. If you're off the button, the trans brake's not active. So, but that is how you set up and read off buttons and how you use them. So, and for instance, say for instance we wanted to do something different where we just wrote the LED pin high whenever the button's pressed. It would be an if statement again. If the digital read of the button pin is high, it would be digital write LED pin high. Or then else. You would put an else statement in there, and then if the digital read of the button pin was not high, which is the else statement, you would digital write the LED pin low to turn it off. You can go into the else statements again. Arduino reference is a very good place to go. So if you need more information on how to use if and else statements, they are here, and they go again to the whole equal sign deal. You know, single equal sign is the assessment operator. The double equal sign is a comparison operator. It goes into very good detail about that, and then you can go into the else part, and it's going to go and show you how the else statement works. So highly recommended read if you are a little fuzzy with using if and else statements in Arduino. But for now, we are going to continue on. So we got the whole buttons input figured out with wiring it into the Arduino, and now we've got it figured out with coding. So we're going to move on to the analog inputs. So for the analog inputs, we are going to excuse me. Okay. So we're going to have to analog read. We're going to take that, copy. So next if statement in the void loop will be, or not if statement, but we're going to digital read, or dial read's going to equal analog read. No. That should be dial pin, I believe. Yeah, dial pin. So, alright, so dial read, which is a volatile read, is now equal analog read of the dial pin. So now we're going to print that out onto the serial monitor. So wait, first we're going to map it, then we're going to print it. So now we're going to take the mapped dial reading, copy, come down here. So mapped dial reading equals map of the dial pin and comma 1 to 1022 and 0 to 100. Alright, so just to go over what we did here, Arduino reference, and we're going to go down to the map. On the map, this is what we just did. So pretty much it, in the description, remaps a number from one range to another, and here is the function down here. So X was the dial read we had before, and Y is the mapped dial reading. So we took that and we brought in the dial read and low to high, and then we went low to high. Also, just to show you, bring up the reference, whenever you do an analog read, I think is 0 to 1023. Yes, 0 to 1023 is your scale on analog read. That's between 0 and 5 volts on an Uno and a Mega. And this analog read page goes over the different computer or different Arduinos and different ways of doing the code, example code, so on and so forth. And again, as I said in the first video, if you don't have the Arduino referenced bookmarked by now, I highly recommend bookmarking it. It comes in handy. So I have found in R&D that if you were to set the bottom and the maximum of that analog read to 0 and 1023, at 0 it's going to bounce around between 0 and 1, and at 1022 it's going to bounce around from 1022 to 1023 because the potentiometer can't bring it to perfect 0 and perfect 5 volts. So I always go up 1 and down the other, or down 1 on the other side of the scale, so that way you can get a clean 0 and a clean 100 output from the mapped dial reading. So we went 1 to 1022 and then 0 to 100. Now if you wanted to change the way this was, you could go 1 to 1022, 100 to 0, so that way, as I showed you earlier in this video, that all the way counterclockwise, that pin was set to ground, and then all the way clockwise, that pin was set to 5 volts. If you wanted to keep it that configuration, but wanted to change how it was printed or saved in the Arduino or printed on serial monitor, so whatever, you could switch that scale to where all the way counterclockwise reads 100 and all the way clockwise reads 0, or you can change the scale. It doesn't have to be 0 to 100. It could be like 50 to 70 or whatever you want. But for this example, we're going to do it this way, where dial pin, the analog read part of it's 1 to 1022. That's pretty much a constant. And then the mapped output 0 to 100. Now we're going to serial print it onto the serial monitor. So we're going to go down here to serial.print, and again ln, because we want it to pretty much hit the enter button or go down a line every time it prints this out, or it drive you insane. So ln, and then we're going to print, I still have that saved, so control V, the mapped dial reading, and then this. So whenever you don't have a serial print in commas, it will print out that reading. So that reading is going to be somewhere between 0 and 100. So printing this just prints a number between 0 and 100, wherever it's the mapped dial readings at. If you have it in quotations like I do up here with this guy, that prints out an actual typed out, whatever you have in between the quote marks is what it's going to print on the serial monitor. So now that this is all done, it should be good to go. Let me check it here. Just do a visual look over, make sure I didn't mess anything up. Now that this is all done, and I still might have messed something up somewhere, we are going to verify it, and this is going to make you save it. So this is going to be the intro sketch for video 2 in Arduino series. Now it's going to compile and make sure I didn't screw anything up. then I think I'm going to show you once it gets done compiling what it does when I screw up. So it did compile. It's using 7% of the program space and 10% of the dynamic memory. So I'm going to purposely screw this up so that way you can see what the heck happens. I'm going to take this and just remove it and hit compile, and it's going to kick it. There we go. So it was expecting that token before this token. So once you put this back in, and it won't compile like that at all. It literally gives you an error message, and that's the end of it. So you just put that back in, you verify your code. And I'll be honest with you, sometimes when the compiler doesn't compile code, and it's telling you this, it's not always a dead giveaway. That's what it is, and sometimes you will pull your hair out trying to find what you did wrong with your code. Definitely, if you're new at it, don't feel bad. I went through it. I still go through it. I'm definitely not perfect at it, but it still happens. And that is, again, a very handy tool for debugging, to figure out, try to figure out why the compiler is not happy and why it can't compile to get ready for programming. So now that this is compiled and ready for programming, I'm going to videotape me throwing it on the Arduino, uploading it to the Arduino, and show you how the Arduino functions after the upload. Okay, now that the sketch is completely done, or we believe it's completely done, we're going to upload it to the Arduino. So, with this, I didn't mention this, the starter kits come with a USB cord. They come with a printer end on them. So, highly recommend going to any kind of store that sells electronics for like printers or whatever, and get a longer cord. So I'll have a regular USB on one end and a printer set up on the other. 10-foot cord, maybe 5, I don't know. I don't know what size you want, but this is maybe like 1.5 feet. It's good for doing benchtop stuff, but whenever you get into putting stuff in cars and whatnot, and you're going to need more cord to hook up to it, highly recommend getting a different cord. So a longer cord. I have a few of them. But anyway, so hook up the Arduino. Make the Arduino smile. There we go. Now, let's see if I can get this. Alright. And now we're going to find this Arduino. COM sticks, got it. Set up for the Arduino, and then we're going to upload. So it's compiling right now. And it's uploading. Okay, and we're done uploading. So, theoretically, see how the LED's turned off? If I hit this button, the LED turns on. Hit the button again, the LED turns back off. So the button input's working, turning on and off the LED. Now the trick is going to be bringing it up on the serial monitor to see how the analog read is working off of the potentiometer. So now we're going to go into serial monitor, and just to show you what serial monitor is, or before we go to the serial monitor, I'm going to show you, I found out I had one little blimp of code incorrect on this. So, and I'm going to bring it up on the screen right here. This mapped, it was mapped to dial reading. I had dial pin, not dial read, which means it was trying to map a 0 to 1 input, and it can't do that. So, just to show you, I did have to switch this. I'm going to highlight it on the screen right there. I had to switch that to dial read instead of dial pin. I flashed it to it. I haven't even checked it yet to see if that fixed it or not, but we're going to go into serial monitor, which is under tools. Click serial monitor. It restarts the Arduino, and it looks like it's going to work. So right now the dial is at 0, and we're going to increase the dial, and look at that. Dial 70, 80, 90, and 100, and all the way back down. And you can see on the screen how fast this updates. All the way to 100, and all the way back to down 0. And say for instance, I got it at, I don't know, what's 66, and you can still hit the button switch, and it goes and it increases the, or sorry, turns the LED on and off. So, just so you're aware, that is still functioning the way it's supposed to. And again, I just screwed up that one. It was dial, it needed to be dial read for the mapped reading, not dial pin. I was trying to map the pin number, and you can't quite do that. But that is something you'll find in R&D. Whenever you're messing with code and you're developing stuff and something's not working correctly, you'll just have to go into the code and figure out what's wrong, what's not liking. And right there, when I brought up the serial monitor the first time, it was a straight line of ones, and I'm like, that knob is down to 0. That should not be ones. So, but that is how you bring that up. I'm actually going to comment out, bring the screen back up here, comment out the serial print for the mapped dial reading output, and then upload this, and I'm going to show you how to do the plotter, because this should plot. So we're writing the new code, it's uploading, okay, it's done uploading, so tools, serial plotter, and there we go. So as you can see on the screen right now, we have a 0 line. So if I turn this knob, you'll watch it increase and decrease on the plotter. I'm just going back and forth, if you can see on the camera. Up and down, up and down, up and down. So you can plot your readings too on the serial plotter part of the program. But that is the end of this second video for the introduction to Arduino. The next video I will put out will be more advanced stuff. CAN bus communication is probably going to come up in the next video. I think I'll go over the data logger. So the data logger goes into advanced analog inputs, data logging with it, like going into SD card setup, more switch inputs for turning on and off the SD card, LED output. That's not the onboard LED set, but you can see that it's currently data logging. Going into saving data to the SD card, and Megasquirt CAN messages, reading the messages off. That might become a little bit advanced. I'm not sure how far into that video I'll go with that. I'm going to go over it completely, and it might be in the next video. Not totally sure. But if you like this video, please hit the like button and subscribe to the channel. If you have any questions, comments, anything I screwed up, please comment on the video. I love hearing from you guys and seeing what you guys think of the video. So thanks for watching, and be on the lookout for the next video coming up in this series.